Hi, I'll be going through an example of one application of the jackknife method, cross-validation. Cross-validation is a way of measuring the accuracy of classifiers, model fits, or other applications in model selection. To use cross-validation, we divide our dataset into k subsets and fit the model using k-1 of those sets, then use the remaining test set to measure some parameter to verify the model. This process is then repeated k times and the aggregate parameter is used to compare the models. It's easy to see how the method parallels the jackknife method. Now, one type of cross-validation is called n-fold cross-validation. In this procedure, we choose k to be n, the total number of points in the dataset. Here we are only leaving a single point out from each fit, so it really is just like the jackknife. We will be using this method to compare 4 different regression models and choose the best one. Here's the data we'll be using. This comes from the DAAG package and can be found in the textbook on page 208. The chemical and magnetic variables represent 2 different methods of measuring the iron content in slag, which is a waste product from refining or smelting ore. And there are 4 different regression models that we are interested in comparing: a linear fit, quadratic, exponential, and a log-log fit. Taking a look at all the models, you can see that they all look like decent regressions, so you can understand that without verifying and comparing in some way, it may be easy to choose a suboptimal model. That's where the cross-validation comes in. And let's go over exactly how we will run the cross-validation. So here is the procedure for estimating the mean square error. Essentially, we're going to be fitting a regression line n times with one xy pair left out each time, computing the difference between the model's prediction and the actual value and storing that into a vector. When that is done, we'll take the mean of the squared errors and get our metric for comparing the models. On the left is the R code for this procedure. It all fits nicely into a for loop, taking one point out, getting a regression, and finding the error for all 4 models. The results are in this table at the top here, and the quadratic fit turns out to be the best of these. Now that we have our selected model, we can make a residual plot and QQ plot of the residuals, which seem normal, and take a look at our fit with all of the coefficients in place. Now let's compare this method of model selection with some others that are commonly used. So we've got the estimated mean squared error from our cross-validation method, the root mean squared error from the full model with all the points, and the adjusted R squared. Both mean squared errors are least for the quadratic model, and R squared is the greatest. All of this is to be expected. But what if we took a look at a different model that would more highlight the usefulness of the n-fold cross-validation? So this example comes from the textbook problem 7.10. It asks us to consider the cubic model in regards to this data set and compare it with the ones that we've already created. These are the results after performing the n-fold cross-validation on the new cubic model. The thing that we are interested in comparing is the adjusted R squared and our cross-validation result. Adjusted R squared is actually larger for the cubic fit. If our analysis had concluded there, we would have probably decided to use this, but we have used cross-validation, and cross-validation says that the cubic model is still worse than quadratic. Why is this? Essentially, performing n-fold cross-validation protects against overfitting. This cubic model is a good example of this. Taking a close look at the plot, it's easy to see that the only point affecting the cubic term is the first one in the lower left. Imagine the cubic regression model fit without this point. It would be a wildly different model, unable to accurately predict this point. While the cubic model might have a higher adjusted R squared, it is less robust in regards to new data and is therefore not the optimal model. So that is a couple examples of n-fold cross-validation, which functions like the jackknife method. I hope you find this interesting and potentially useful. Thank you.